In this example, we want to find the equation of a tangent line to the hyperbola y equals 3 over x at the point 3 comma 1, and to do this, we want to use the definition of derivative. Before I get started, I'd like to give you a visual of what we're doing. Here's a portion of the graph y equals 3 over x that contains the point 3 comma 1. And we want to find the equation of a line, a tangent line, that passes through that point. Notice that on this line, we have a point 3 comma 1. So we can write the equation of this line given a point, and if we can find the slope, in point-slope form. Okay, so all we need is the slope. And that's where the definition of derivative comes in. So I want to walk you step by step of how to find the derivative applying the definition of derivative. Okay, so the first thing I want you to notice is that in this definition, we have a limit as h goes to 0, and then we have this portion of the definition. So let me walk you through how to do this portion. The first thing that we notice is this right here. What is that telling us to do? That tells us to go to our function and input x plus h. Here's our function, here's our input variable, and this is telling us to input x plus h in to our input variable. So let's do that. So we have 3 over x plus h. Then it asks us to subtract f of x. Well, f of x is your function. So I'm going to subtract 3 over x. Place everything over h. And we have the limit as h goes to 0. At this stage, normally what we do with the limits is we apply the limit by replacing all the h's with 0. Well, we skip that step in the definition derivative because this is always going to happen. If I put a 0 in here, I get 3 over x minus 3 over x, which is 0, all over 0. I get 0 over 0, which is indeterminate. That always happens with the definition derivative. So we just usually skip right into simplifying what we have here. I have a complex fraction right now, and I need to write that as a simple fraction with one numerator and one denominator. So let me take you through the process of writing this simple fraction. The first thing that I notice here is that we have one fraction subtract another fraction on top. Anytime you subtract fractions, you're going to want a common denominator. So let's find the common denominator. In algebra, the way we find common denominators when variables are involved is we just multiply the two together. So our common denominator here would be x multiplied by x plus h. Okay, so if you look here, this denominator to be common, I need to multiply by x. If I multiply the bottom by x, I need to multiply the top by x. So we have 3x on top. Okay, moving to the next denominator, we have x. To be common, I need to multiply it by x plus h. Okay. If I multiply the bottom by x plus h, need to do the same thing to the top. Okay, if we distribute that, I would have a negative 3x and a negative 3h. We have this h here on bottom, limit as h goes to 0. Let's simplify the top. Notice that a 3x and a negative 3x cancels, and I have a negative 3h over x quantity x plus h, all over h, limit as h goes to 0. Okay, now this h right here, I can rewrite that as h over 1. And I want to do that because now I have a fraction divided by a fraction, and when you have that, you can multiply by the reciprocal of the denominator. Okay, so let's do that. So I'm going to multiply by the reciprocal right here. Okay, let's just clean that up a little bit. So on top, if I multiply, I have negative 3h. On bottom, if I multiply, I have h times x plus h. Okay, and that is the limit as h goes to 0. Okay, now, this h right here can cancel with that h right there. And that's key, because what just happened is, remember earlier I said we had indeterminate, we had 0 over 0? That just canceled, so we don't have that issue anymore, which now allows me to apply my limit. So I'm going to substitute 0 in for that h right there, and I have a negative 3 on top, and I have, looks like x times x is x squared on bottom. All right, and this is my derivative. Okay, now remember, we have the point already, 3, 1. We just need the slope. That's exactly what the derivative function does. It'll give you the slope. You just tell me the location on this curve, and I can tell you the slope. And this location is dependent on x. All right, so right here. 3 is my x value, so dy dx is equal to negative 3 over 3 squared, and that simplifies to negative 3/9 or a negative 1/3. Okay, that's our slope at that point. Okay, now all we have to do is write the equation of the tangent line. We have the slope, we have the point, so let's finish this off. Y minus 1 equals x minus 3 with my slope, negative 1/3 in front. Now that's in point slope form. They didn't ask us for any other form, so that's okay, that's sufficient. So I'm just going to take a moment real quickly and change this from point slope into slope intercept. That's simply distribution. Let me go ahead and do that. So I have negative 1/3 x, a negative 1/3 times a negative 3, that's just positive 1. All right, and then just add 1 to both sides. And I have y equals negative 1/3 x plus 2. That's the equation of the tangent line in slope-intercept form. Remember, the definition of derivative comes from 2 points on the curve, the point of tangency and some other point that we choose some distance away we call h. Let's just take a quick look of that second point on the curve, some distance h away, and what this limit does. Okay, so there's the equation of the tangent line. All right, now the definition of derivative, that h is talking about a second point that we put on there, some distance h away. I just want to give you a visual of quickly what happened here. So I just chose some other point, h distance away, and we connect those 2 points. That's called a secant line. That limit as h goes to 0, this is what's happening. So that point is getting closer and closer until it becomes a tangent line. That is the equation of the tangent line. Let's check it out and see how well it matches our graph. Okay, so according to our tangent line equation, our tangent line should have a y-intercept of 2. That looks good. And according to our equation of tangent line, we should have a slope of negative 1/3. Looks like we go down 1 over 3. Looks perfect to me. That wraps this up. So I hope this video was of some help to you. I'm going to link my video, the definition derivative, at the end of this. Watching that video can help you unlock the key to understanding this whole definition derivative. So thank you. I have other videos that are coming and other videos that are already out there to help you understand derivatives, the rules of derivatives, application derivatives, limits, all those, some pre-calculus as well. Thank you for watching, and we'll see you next time.